I'm Dr. Lena Popovic, and after 30 plus years in medical practice, I realised there's a lot missing from modern medicine. Education is more powerful than medication, and our decisions have more impact than our DNA. Today's brain booster is go with your gut. Is your gut sensitive, irritable, leaky, or inflamed? Are you into prebiotics, probiotics, postbiotics, synbiotics, psychobiotics, pharmabiotics, antibiotics, penbiotics, or panbiotics? And I will explain all those terms shortly. Why does it matter? Because for most of modern medicine, the brain and the gut were treated as separate organs with separate problems. If you had indigestion, you saw a gastroenterologist. If you had memory loss, you saw a neurologist. Today, that division is fast disappearing because what happens in the gut doesn't stay in the gut. Scientists now recognise that our gut and our brain are in constant communication through what is known as the gut-brain-microbiome axis. Signals travel back and forth every second via nerves, hormones, immune pathways and chemical messengers that are produced by the trillions of microorganisms or microbes that live in our intestines. The estimated number of microbes in our gut is about 40 trillion. We used to think it was 100 trillion. We now think it's probably closer to 40 trillion. Still an unfathomable number. With a combined total weight of over 2 kilograms. You're carrying 2 kilograms of bugs in your gut. That's more than the weight of our brain, which is 1.4 kilograms. And our microorganisms have evolved to play essential roles in maintaining our health. They help us digest food. They control how many calories we absorb. That means they influence our body weight and our risk of obesity. They impact our mood. Bacteria produce vitamins. They synthesize B1, thiamine, B7, B9, folate, B12 and vitamin K, and they facilitate absorption of minerals like magnesium, calcium and iron. Bacteria help maintain the intestinal barrier so that toxins and infectious agents don't leak from our gut into our bloodstream. Bacteria can also neutralise many of the toxins we ingest, so if you have fewer detoxifying bacteria, you increase the workload of your liver. Your microorganisms educate your immune system to recognise what it should and shouldn't attack. And your gut bugs influence the development of asthma, allergies, autoimmune diseases, diabetes, depression, dementia, heart disease, cancer, and a whole lot more. In fact, gut bacteria predict a person's likelihood of developing obesity better than their genes. More on this later. And an unhealthy gut creates an inflammatory cascade that can accelerate cognitive decline, promote protein clumping in the brain, and significantly increase the risk of developing dementia. So let's take a closer look at how problems in our gut can lead to problems in our brain. A healthy intestinal lining acts as a selective barrier. It allows nutrients to pass into the bloodstream while keeping harmful substances out. When this barrier becomes compromised, known as increased intestinal permeability, or the colloquial term leaky gut, which was actually regarded as nonsense only a few decades ago, but when your gut gets leaky, bacterial fragments such as lipopolysaccharides, always abbreviated LPS, can enter the circulation. The immune system responds by producing inflammatory chemicals, and these inflammatory signals can reach the brain where they reduce mental clarity, impair memory formation, alter mood, and accelerate neurodegeneration. And from listening to my previous podcast episodes, you know that inflammation is increasingly recognised as a major contributor to all chronic diseases, including Alzheimer's and other dementias. Another mechanism by which healthy gut microbes contribute to brain function is by producing what are known as short-chain fatty acids. Examples are butyrate, acetate, and propionate. And these short-chain fatty acids are primarily produced in the gut by microbial fermentation of dietary fibre. But they can also be generated through alternative pathways. So people following a low-carb diet or even a carnivore way of eating, they can still produce short-chain fatty acids as long as they're not eating processed foods. And the importance of short-chain fatty acids is that they also help lower inflammation, maintain the integrity of the gut barrier, and support the robustness of the blood-brain barrier. And the blood-brain barrier is a specialised filtration system that keeps toxic substances out of your brain. So you don't want your blood-brain barrier deteriorating and allowing harmful substances into your brain. But when the diversity of microorganisms in our gut declines, as happens whenever we take a course of antibiotics or eat processed foods or drink a lot of alcohol, our blood-brain barrier becomes more permeable. A third crucial mechanism that links gut health to brain health is through bacterial production of neurotransmitters like serotonin, dopamine, GABA, and acetylcholine. Who would have thought that gut bacteria make neurotransmitters, chemical messengers that influence brain function? And I'll elaborate on this in a minute, but I just want to give you the big picture first. There are also indirect ways that gut health influences brain health. Poor gut health is associated with a host of other conditions that increase the risk of dementia, namely depression, anxiety, excess fat around the abdomen, referred to as abdominal or visceral obesity, insulin resistance, type 2 diabetes, cardiovascular disease. They all increase our risk of dementia. And that's why today's brain booster is to go with your gut, both literally and figuratively. In the literal sense, pay attention to the physical signals and sensations coming from your stomach and intestines because they communicate important information about your overall health and your mental state. Don't think that gut problems are confined to your gut. They could be a precursor to brain fog, dementia, and Parkinson's disease. So I strongly encourage you to implement the gut healthy habits I'll discuss in this and the next podcast episode. Because this is such a huge topic, I don't want to overload you in one hit. So we're going to explore the exciting world of gut health over 2 episodes. I'm also using the phrase, go with your gut, in the figurative sense. Trust your intuition, your subconscious feelings when making decisions, because those gut feelings are biologically valid. Your brain processes vast amounts of information from past experiences and environmental cues faster than your conscious thoughts can keep up. And when your subconscious mind notices danger or an opportunity, before your conscious mind does, it sends signals down to your digestive system. So when you follow your intuition, you are quite literally responding to the physical sensations like butterflies, tightness, nausea, a sinking feeling, generated by your gastrointestinal tract in response to subconscious wisdom. Okay, now let's rewind and go back to how the gut-brain connection was first discovered, because it's a fascinating story. In the summer of 1822, a French-Canadian fur trader on Mackinac Island in Michigan, called Alexis St. Martin, was accidentally shot with a musket, a long gun, from less than a metre away. The doctor who rushed to the scene was Army surgeon William Beaumont. He found Alexis gasping for life with a hole larger than my fist in his upper left abdomen. When Dr. Beaumont peered inside the hole, he could see that Alexis's stomach also had a hole in it, albeit smaller, the size of my index finger. Through his excellent surgical skills, Dr. Beaumont was able to save Alexis' life. But he wasn't able to close the stomach wound. So Alexis was left with what's known as a gastric fistula. That's a permanent hole in his stomach that was connected to his skin via an abnormal tunnel that opened to the outside of his body. And this can still happen with stomach wounds today because stomach acid, digestive juices and food continuously wash through the wound and break down any newly formed tissue, so it prevents the edges from sealing. And what happens then is the stomach lining, called the mucosa, grows outward and connects directly with the skin. And once these tissue tracts are lined with mucosa, a process known as epithelialization, the body no longer recognises it as an open wound that needs to close, and it stays open. Now, I don't mean to gross you out with the details, but it's important for our story for you to understand what was happening. Because as a result of the accident, Alexis was no longer able to do the physical work of a fur trader. So Dr. Beaumont, from the kindness of his heart, hired Alexis to be his live-in handyman. In truth, however, he hired Alexis to be his guinea pig. Now, I don't know all the details of their domestic arrangement, but when Dr. Beaumont relocated to New York, he took Alexis with him and started to do some weird experiments with Alexis' digestive tract. For instance, he got a silk string and tied to it small pieces of boiled beef, okay, maybe a bit smaller than that, chicken, raw cabbage, stale bread, and other foods, and then dangled them in Alexis' stomach for varying lengths of time before pulling them out to test how stomach juices digested food. It was 1822 after all, and there was no social media, so they had to come up with other ways to entertain themselves. But the reason Dr. Beaumont was doing these experiments was to answer the question, how do we digest our food? What chemicals are involved? Because in those days, we didn't know. So Dr. Beaumont would send these bits of partially digested food to be analysed in a laboratory. And that is how we came to know that the stomach is highly acidic and contains the digestive enzymes pepsin and gastric lipase. Before then, people thought it was purely the mechanical action of the stomach that broke down food. They had no idea that it was enzymes working alongside strong stomach acids that liquefied our food so that it could be further processed in the small intestine. But Dr. Beaumont also inadvertently discovered something else. Alexis, not surprisingly, didn't always enjoy these experiments, and sometimes he got irritable. To Dr. Beaumont's surprise, when Alexis became angry, his digestion slowed down. When Alexis was in a calm state, the food was digested more efficiently. This was the first documented observation that different emotional states can increase or decrease activity in the gut. Several decades and 238 experiments later, Dr. Beaumont died in 1853, having opened the door literally to the gut-brain connection. Alexis, on the other hand, outlived Dr. Beaumont for another 27 years, going back to work as a voyager and farmer before passing away at the age of 83. Unfortunately, no one thought much about the significance of Dr. Beaumont's gut-brain observations, so the subject was pretty much left unexplored. Fast forward 1 century. In 1946, an army physician, looking after a soldier with extensive parts of his small and large intestine exposed, saw that when the patient became more distressed by the arrival of other injured soldiers, both his small and large intestine became more active. Then, in the 1960s, gastroenterologist Thomas Almy monitored colon activity in people while they were being interviewed about emotionally charged topics. And what he found was that hostility and aggression made the colon contract more quickly, whereas hopelessness, self-reproach, feelings of inadequacy, they caused the colon to contract more slowly. Finally, interest in the gut-brain connection was ignited. So when we talk about gut health, we're talking about a system with three inseparable components. One, the gut cells themselves that make up the gastrointestinal tract from our mouth to our anus. Two, the nerves and nerve cells, neurons, that are interwoven with our gut cells and that make up what's known as the enteric nervous system, ENS. And the third component of gut health is the trillions of microbes that live in every nook and cranny of the gut. Together, these three entities, our gut, its neurons, and its microbial residents, form an amazing information exchange system. Now, this might seem pretty evident to you now, but only a few decades ago, we're not talking centuries, only a few decades ago, the gut was considered to be nothing more than a tube that broke down and absorbed food and eliminated what we didn't need. Today, the gut is even referred to as our second brain because of the 100 million neurons lining its walls from esophagus to rectum. That's about the same number of neurons as in the brain of a cat. Imagine that. You have a cat brain in your gut. And this gut nervous system, the enteric nervous system, not only controls our digestive processes, it also mediates gut activity in response to different emotional states, especially stress, as first observed by Dr. Beaumont. So as I said at the start, our brain and gut are in constant bidirectional communication via three channels. One, a long, large nerve called the vagus. Two, the bloodstream. And three, our immune system. And we call this the gut-brain-microbiome axis. Sometimes people will just use the term gut-brain axis, but adding the word microbiome, which refers to our gut microorganisms, is the more precise term. So in today's health headline, we'll look at each of these components in turn, how they work together, and how we can use this information to maximise our brain health as well as our physical and mental health. Because what's good for the gut is good for the brain, is good for the heart, is good for the lungs, is good for the skin. You know the drill. Today's health headline is, what's your gut reaction? In other words, what is going on in your gut and why does it matter to every aspect of your health? Let's start with our gut microbiota, the organisms that call our gut home and that form an invisible but indispensable internal ecosystem. Now, just to clarify some terms you'll frequently come across: microbiome, microbiota, and metabolites. Microbiome and microbiota tend to be used interchangeably, but to be precise, microbiome refers to all the genes of all the microorganisms that reside in a specific location in our body, and that location is referred to as their environmental niche. Whereas microbiota refers to the organisms themselves, also called microbes or commensals or flora. So the microbes in our gut are referred to as our gut flora. On our skin, we have skin flora. In our lungs, we have lung flora. In our vagina, we have vaginal flora. You get the picture. So microbiota are the organisms, and microbiome refers to their genes. And we don't just have bacteria in our gut. We also carry viruses, fungi, and organisms called archaea. It's just that the viruses, fungi, and archaea occur in much smaller numbers. So to be really precise, scientists will refer to the bacterial portion of our microbiome as the bacteriome, the viral portion as the virome, the fungal portion as the mycobiome, and the archaean portion as the archaeome. And I'm deliberately going into this level of detail so that you understand there are too many different organisms interacting in too many different ways for us to have figured out what constitutes a healthy mix of microorganisms for any individual person. Our gut is absolutely teeming with activity, and there is still so much we don't know about how all these organisms interact with each other and how they interact with us. So when someone tries to tell you a specific probiotic supplement will solve your gut issues, it's guesswork and it's wishful thinking. I'm not saying there's no chance of a probiotic being helpful. I'm saying in most cases it's potluck if it does. More on probiotics later. And here's another important thing to know about the microorganisms that can find their way into our body. The bacteria, viruses, fungi and archaea in our gut can behave in 3 ways. They can be good guys, called symbionts, as in symbiotic, as in mutually beneficial relationship. 2, they can be harmless most of the time, but don't do anything to upset them or they'll start to cause trouble. They're called pathobionts. Or 3, they can be downright bad guys called pathogens. The good guys, symbionts, are our natural inhabitants and they are indispensable to our good health. An example of good guys are bacteria that belong to the Lactobacillus family. Actually, it's the Lactobacillus genus, but Lactobacilli, good guys. The sometimes good, sometimes bad guys, the pathobionts, are also natural inhabitants of our gut, and they usually live peacefully alongside symbionts and are typically harmless, or they might even be beneficial. However, if our immune system becomes compromised, or if drugs or dietary choices disrupt the natural balance of our gut bugs, these microbes can be triggered to promote inflammation or disease. An example is the bacterial species Clostridium difficile, abbreviated C. diff. Under normal circumstances, C. diff is kept in check by other gut bacteria. But if a person is on a course of antibiotics that wipe out the symbionts, C. diff can overgrow and cause a severe life-threatening infection. As for the downright bad guys, the pathogens, they are not normal inhabitants of our gut. Pathogens are acquired from polluted water, contaminated food, or shaking hands with an infected person, then touching your own face or eating without washing your hands. Examples of pathogens are Salmonella and E. coli food poisoning. Another important term, a very important term, is metabolites. Now, metabolites are the chemical byproducts of the activity of our microbiota. In other words, metabolites are the intermediate and end products produced when our gut bacteria digest and break down food, or they act on an existing compounds in our gut. And microbial metabolites are absolutely critical to our health because they influence our brain development, our behaviour, digestion, food cravings, immune system, hormones, and probably a lot more we've yet to discover. So the metabolites produced by our bacteria are actually more important than the bacteria themselves, because the same bacterial species can produce either healing chemicals or harmful chemicals, depending on what we feed them, how much stress we're under, whether we've had a good night's sleep, and even how many hours a day we spend sitting. Refer to podcast episode 5, Sitting is the New Smoking. But I'm getting ahead of myself. Just be aware that microbial metabolites, all the different chemicals produced by our bacteria, act as the primary communication signals between our bugs and our body. And they influence everything, from digestion and immune health to brain function and metabolism. And the scientific field of studying microbial metabolites is known as metabolomics. It's a brain booster just learning all these new words. Now, gut microbial metabolites fall broadly into 3 categories based on how they originate. And I'm going into this level of detail because it lays the foundation for understanding how we can all improve our gut health. The first category of metabolites are the chemicals that bacteria produce from what we eat. For example, bacteria in the colon ferment indigestible carbohydrates like fibre into highly bioactive compounds that lower inflammation and reduce the risk of colon cancer. The second category of substances produced by our gut microbes is referred to as microbe-modified host compounds. What that means is that the host, i.e. your body, produces substances that gut bacteria then change. For example, primary bile acids, synthesized by your liver, pass into your intestine and are biochemically modified by enzymes from your gut microbes. And the third category of microbial metabolites come from what's known as de novo synthesis. These are compounds manufactured completely by the bacteria themselves, for example, vitamin K and certain amino acids. So what are some specific microbial metabolites and why are they so important? The ones you'll hear most about, I've already mentioned. Short-chain fatty acids such as butyrate, acetate and propionate. They provide energy for the cells lining your colon. They help regulate inflammation, balance blood sugar and influence appetite. Within the second category of metabolites, I mentioned bile acids. Now, your liver produces primary bile acids to help digest fats. When these enter the large intestine, gut microbes transform them into secondary bile acids, which act as signalling molecules to manage cholesterol, glucose and energy. Then you have tryptophan and indole derivatives such as serotonin and melatonin. These are produced when bacteria break down the amino acid tryptophan into chemicals that help maintain the integrity of the gut barrier and regulate immune responses. In fact, more than 90% of the body's serotonin is produced in the gut and less than 10% in the brain. Likewise, the gut produces the vast majority of the body's melatonin. The exact percentages of melatonin production are difficult to measure, but estimates suggest the gut and its microbiota are responsible for up to 90% of the body's total melatonin, creating at least 400 times more of the hormone than the pineal gland in the brain. Hence, sleep is both influenced by and influences our gut microbes. And our gut microbes also produce or influence levels of neurotransmitters such as GABA, which stands for gamma-aminobutyric acid, and dopamine. Now, GABA is a calming chemical, while dopamine is a key neurotransmitter responsible for motivation, reward anticipation, and reinforcement. A lot of people refer to dopamine as the pleasure chemical. But rather than directly creating pleasure, dopamine drives you to take action because you anticipate pleasure, and it reinforces behaviours by rewarding you when you achieve a goal. And dopamine is critical for maintaining healthy moods and cognitive function. So you can see why having a healthy gut populated with a healthy mix of microbes, producing a healthy cocktail of chemicals, plays a massive role in maintaining our physical and mental health. And why today's brain booster is to go with your gut. Now let's look at some extraordinary numbers. The microbiome, the genes of all the microorganisms in our body, accounts for more than 95% of the genes in our body. Let me rephrase that so that you can get your head around it. Of all the genes in your body, less than 5% belong to you, and more than 95% belong to your microbes. It's estimated there are more bacteria in our gut than there are stars in the Milky Way. And if that's not impressive enough, 1 gram of feces contains more bacteria than there are people on Earth. That's right, a single gram of human feces, about the weight of a paperclip, contains up to 100 billion to 1 trillion bacteria. By comparison, the entire global human population is about 8 billion people. 1 tiny gram of your stool has over 100 times more bacteria than the population of this planet. So you can actually think of your own body as a planet. It's inhabited by trillions of creatures, adapted to the various environments provided by different parts of your anatomy. And as I said earlier, most of our 40 trillion resident microbes are bacteria, but we also house viruses, fungi, and archaea. So there's no reason to ever feel lonely. The most densely populated region of our body is our colon or large intestine, which isn't surprising because the surface area of our gut is more than 100 times greater than the surface area of our skin. And when it's fully stretched out, because it's highly coiled inside our abdomen, our gastrointestinal tract is on average about 6 metres or 30 feet long from mouth to anus. Our small intestine is actually the longest section, about 6 to 7 metres or 20 to 22 feet, and it does most of the heavy lifting in terms of absorbing nutrients. The large intestine is only about 1.5 metres or 5 feet long, but it's called the large intestine because it's much wider than the small intestine, and it primarily absorbs water. And the remaining length of our GI tract is made up of our mouth, throat, i.e. pharynx, esophagus and stomach. And inside your colon, right now, an estimated 1,000 bacterial species are breaking down food, manufacturing vitamins, buffering toxins, and keeping harmful infections at bay. But it isn't just the gut that serves as potential real estate for microorganisms. It's every surface of our body exposed to the outside world. That means skin, nose, ears, mouth, teeth, lungs, and vagina. And our microorganisms are very, very specific about the environments they need for their survival. Like humans, what matters is location, location, location. Some microbes prefer the intense acidity of our stomach. Others, the salty moisture of our armpits. Body odour is produced by bacteria, both pleasant and less pleasant. There are at least 500 different known species, or phylotypes, in our mouth alone. And they're so fussy that the microbes living on our front teeth won't live on our back teeth. And the ones living on the front of a tooth are different from the ones on the back of that same tooth. There must also be something different about our left and right hands, because only 17% of the microbes that live on the left hand also live on the right hand. This comes from a 2008 study published in the journal Proceedings of the National Academy of Sciences, PNAS. Led by researchers at the University of Colorado Boulder, the team used advanced genetic sequencing to map the unique bacterial fingerprints on the palms of 51 healthy undergraduates. And they discovered that a typical palm harbours more than 150 different bacterial species. But over 80% of those species differ from one hand to the other on the same person. Why might this be the case? Well, firstly, your dominant hand is constantly touching different objects, a computer mouse, doorknobs, keys, compared to your non-dominant hand. So your dominant hand is constantly picking up and leaving behind a unique cocktail of immigrant microbes. Secondly, subtle physical differences exist between your two hands. Variations in oil gland production, sweat gland activity, skin thickness, and hydration levels. They all create entirely different ecosystems for bacteria. And thirdly, we have a preferred hand for self-touch. And by that, I mean we tend to use our non-dominant hand more often for personal grooming or touching our face or neck or hair. So once again, that hand is exposed to and transferring a different set of body-specific microbes. The other interesting finding was that unrelated individuals share only an average of 13% of their hand bacterial species, and women have a significantly greater diversity of bacteria on their palms than men. Why might that be? Men generally have more acidic skin surfaces than women. Acidic environments are naturally hostile to many types of bacteria, which limits the variety of species that can survive on male hands. Men and women have differences in sweat gland activity, oil or sebum production, and of course hormone levels, which also affect the moisture levels on our palms. And it turns out that these things make the female hand a friendlier environment for a broader range of microbes. It's also likely that the more frequent application of moisturisers, lotions, cosmetics by women alters the skin barrier, creating distinct microhabitats that support different bacterial communities. Asthmatics have different gut microbes to non-asthmatics. And people who carry more body fat have different microbes to people who are lean. In fact, no two people have the same microorganisms living on their bodies, not even identical twins. Everyone has a unique microbial identity, just as we have a unique fingerprint. And crime scene investigators are now starting to use not only fingerprints, but bacterial prints, referred to as touch microbial forensics, to track down criminals. Because your bacterial inhabitants are uniquely yours. And when you touch something, you leave some of them behind. And whereas standard human DNA and physical fingerprints quickly degrade when exposed to sunlight, heat or moisture, hand bacteria are remarkably resilient. Many of the bacteria living on your skin have evolved to survive harsh, dry environments. So a suspect's unique microbial fingerprint can remain stable and identifiable on an object left at room temperature for up to 2 weeks, and on clothing for up to 6 months. The other thing forensic scientists are doing is using machine learning algorithms to analyse the predictable decay rates of minor bacterial species left on a surface. And by tracking how the community changes hour by hour, the microbiome can act as a biological clock to narrow down the exact time a piece of evidence was touched. And even if a person's microbial profile isn't in a database, their handprint microbiome can provide invaluable clues about their age, sex, dietary habits, whether they take specific medications, the types of hygiene, cosmetic and beauty products they use, and their geographic region or ethnicity. How amazing is that? And one of the reasons that a single diet does not fit all is because of our unique microbial composition. We are not what we eat. We are what our body and our unique set of gut microbes do with what we eat. Different bacteria extract more or less energy, i.e. calories, from the food we eat. For example, people who carry more bacteria called Firmicutes tend to extract more calories from their food than people with a high percentage of another bacteria called Bacteroidetes. What this means is that two people can eat the exact same foods, but one of them gains more body fat because the bacteria in their gut enable them to absorb more of the calories. Firmicutes are therefore referred to as better calorie harvesters, which is great in times of famine, but not so great in times of Uber Eats. Now, not all studies have shown a definitive link between the Bacteroidetes-Firmicutes ratio and a person's BMI, body mass index. But that could be because there are thousands of distinct bacterial species within the Bacteroidetes and Firmicutes families. And it might only be certain species of Firmicutes that are better calorie harvesters. Also, it's difficult to determine if a high Firmicutes ratio causes weight gain or if a high-calorie, highly processed Western diet simply feeds and multiplies Firmicutes bacteria. Another species of bacteria, called Akkermansia muciniphila, also play a role in how much body fat you carry. These microbes, as their name suggests, muciniphila, mucus-loving, they feed on mucin, a special protein that makes up the gel-like mucus lining of our gut wall. And when Akkermansia munch on mucin, it sends signals to the body to produce more mucus and tighten cell junctions and thereby strengthen our gut wall. and that prevents harmful endotoxins like LPS, remember, lipopolysaccharide, from leaking into the bloodstream, which would otherwise cause inflammation. And it also improves insulin sensitivity, which reduces weight gain and lowers the risk of developing diabetes. Akkermansia also produces a specific protein called P9 that triggers the release of GLP-1, a hormone that promotes satiety. And you've probably heard a lot about GLP-1 because all the new weight loss drugs, Ozempic, Mounjaro, Wegovy, mimic this hormone. And here's the interesting thing. About 4% of the microbial community in lean people belong to this species, Akkermansia muciniphila, while obese people have hardly any Akkermansia. So, of course, scientists are bending over backwards trying to create Akkermansia probiotics. The problem is that Akkermansia dies when exposed to oxygen. The name for that type of microorganism is a strict anaerobe. So it's very difficult to cultivate Akkermansia for mass production. However, biotech companies seem to have developed specialised formulations to keep it shelf stable. However, in human clinical trials, the average weight loss over a 3-month period directly attributed to Akkermansia muciniphila probiotics and not due to accompanying dietary changes was only around 2.27 kilograms or approximately 5 pounds. Not that impressive for 3 months. What I did find compelling, however, was that people taking Akkermansia probiotics improved their insulin sensitivity by 28.6%, lowered their circulating insulin by 34%, and they had better markers of liver function. I'll talk about the importance of keeping our insulin levels in check in a future podcast. For now, just know that lowering circulating insulin by 34% is really good for our overall health. But while touted as the next generation super probiotic, clinical research is still only in the early stages, so it might not be beneficial or suitable for everyone. And there are very few health professionals that really know much about this stuff and can give you sound advice. Now, I suspect that some of you will go and look for Akkermansia probiotics and you'll discover that there are different types. Which is the best? The best answer I can give you at this point in time is that some studies found that pasteurized, i.e. heat-treated Akkermansia, yielded slightly better results than live bacteria because pasteurization stabilizes a specific protein on the bacterium's outer membrane that interacts directly with our immune and metabolic systems. That's what the science is saying so far. But as I said, it's still early days. Can you see that the more we learn about our gut microbiota, the more complex and convoluted the picture becomes? But despite the gaps in our knowledge, the good news, this podcast is always a good news story, the good news is that the basics of good gut health are pretty basic. Establishing a healthy gut without pills, powders, potions or lotions is not complicated. That doesn't mean it's easy in our complicated modern world, but it doesn't require modern medical interventions. In fact, it requires quite the opposite. Now, this has been another exceptionally long brain booster and health headline, so I'm going to end this episode here. And I'll continue with what's missing from modern medicine and the weather report next week. Because the feedback I've received from you is that you'd like me to keep my episodes to under 1 hour. So that's what I'll strive to do. Thank you for all your comments and questions. I will respond to them in due course, and I really appreciate your engagement. Please note that this podcast is for general information purposes only. It does not constitute medical advice and is not intended to provide specific guidance for any particular situation. The use of this information is at the viewer and listener's own risk and is not a substitute for consulting a healthcare provider.